Warning! The video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is a continuation of the product and quotient rules for Calculus 1, and we're going to start using the product rule in this video. The previous video introduced us to it, and in this video, we're just going to go ahead and use it. And I'll write it up above in this first example. It is the derivative of f times g is equal to the derivative of f times g plus f times the derivative of g. Technically, you could write it in any order like this, as long as each term has its own derivative. However, I usually follow this order because the quotient rule is very finicky about order, and it likes this order. How's that? So find the first, second, and third derivatives of this function, which is a product of two different kinds of functions, one being a polynomial function, and the other being a transcendental function, which is e to the x. All right, so let's go ahead and take that derivative. Now, I will go slow at first because I think that it's a good idea, right? So we're gonna let f equal x cubed plus 2x, and we'll let g equal e to the x. Now I know that in the derivative, I'll need f prime and I'll eventually need g prime. So let's go ahead and find out what f prime is. F prime of x is bring down the power, reduce the power by 1, and then derivative of 2x is 2. G prime, one of our favorite derivatives, g prime or derivative of e to the x is just e to the x. Now that we have everything written down and set up, the very first derivative, f prime of x, oh, I use the same letters. I apologize. Let me rewrite this. I'm going to call this function h. We'll call this h of x, just because it works a little bit better so that I'm not using f over and over again. So h prime of x is equal to f prime times g plus f times g prime. So there you go. You do want to, since you're going to be using this, you want to factor out common factors, collect like terms and all that fun stuff. So I'm going to rewrite this as x cubed plus 3x squared plus 2x plus 2 times e to the x. I just factored out an e to the x and collected like terms. Now we're going to go ahead and take the second derivative. Notice how this gets a little more complicated. So the basic differentiation doesn't really lead to complications, but when you start taking derivatives of products or quotients, it gets uglier and uglier and uglier. So let's go ahead and again talk about which one is playing the role of f and which one is playing the role of g. And even though they're different letters here, because f technically we define to be that and g we technically define to be that, I'll go ahead and just use f bar, just because it's a different function technically. So f bar is x cubed plus 3x squared plus 2x plus 2. And the derivative of that is 3x squared plus 6x plus 2. And then g bar is actually just e to the x, and its derivative is e to the x. But I'm doing that because I can then just use this. So let's see, h double prime, or the second derivative, is going to be f prime g, so 3x squared plus 6x plus 2 times g, plus f, which is x cubed plus 3x squared plus 2x plus 2 times g prime. Now you get so fast with this that you actually don't have to write these little intermediate steps in. People get very quick with this and they don't need to write down this little table. But initially, I think it's a good idea to do that. Factoring out an e to the x and collecting like terms, you get x cubed. Let's see, you'll have a 6x squared. You'll have an 8x. And you will have a 4. And that would be all. Now, something you need to know is in the long run, you're going to start looking for patterns for these derivatives. This one specifically doesn't have a beautiful pattern to it. I mean, there is a pattern actually. There is technically a pattern in the background, but I wouldn't expect you to find it for this. We'll talk about patterns a little bit later. All right, so let's go ahead. And this time when I do the third derivative, I'm going to showcase how I would use the third derivative here. So remember, I have a function that's playing the role of f, and I have a function that's playing the role of g. So f prime is 3x squared plus 12x plus 8. G is e to the x plus f, which is x cubed plus 6x squared plus 8x plus 4 times the derivative of g, which happens to be just e to the x. So notice how I could do everything all at once. Well, not everything, but most everything all at once, rather than writing out a table of values. You're more than welcome, by the way, to write out this table of function values here. That's perfectly fine. There's no shame in that. Collecting like terms, you get the following: x cubed, let's see, 9x squared, 20x, and a 12. There's definitely a pattern going on, and we would have factored out e to the x. So that is a good use of the product rule, taking the first, second, and third derivatives. And obviously it gets more and more complicated as you move forward. The only other example we have, at least initially, for using the product rule is this guy right here. Because most of your examples using the product rule are just going to be a bunch of products. They're polynomials times exponentials right now. Mainly because, or could be radicals times exponentials, mainly because you don't know how to take the derivative of other kinds of functions. So nobody's going to hand you a logarithm times a polynomial or a trigonometric function times a logarithm or something like that, because we don't have rules to take derivatives of those things yet. So right now you're just taking derivatives of products of objects that you can take derivatives of. So I'm going to go ahead and write the product rule up above. Remember, the product rule is f g prime is equal to f prime g plus f g prime. Suppose that f of 2 is negative 3 and g of 2 is 4. F prime of 2 is negative 2 and g prime of 2 is 7. Find h prime of 2 if h of x is equal to f of x times g of x. That sounds super complicated, right? But really, just start by looking at the final thing they asked there. Find the derivative of that function at 2. Okay, and since that function is a product, I happen to know that its derivative will just be the derivative of the first guy times the second, plus the first guy times the derivative of the second. And therefore, h prime at 2 would be f prime at 2, g at 2, plus f at 2, g prime at 2. And then I say, man, I wish I had those values, until I look up and I see I have those values. They gave me all those numbers. So I just insert. This is just a substitution problem. F prime at 2 is negative 2. G at 2 is 4. F at 2 is negative 3. And G prime at 2 is positive 7. So you have negative 8 minus 21, or a negative 29. So there's some uses of the product rule. Product rule gets used so often that it becomes second nature. What I don't want to ever see is somebody making the mistake of saying, oh, I've got two functions multiplying and I need to take their derivative, therefore it's f prime g prime. That is not true. Don't ever make that mistake in a calculus class. So there's no rule. Remember, really mathematics is just a game of rules. And if you don't have a rule stating you can do something, you can't do that something. That's it.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.